Hey there, what's up guys, and welcome back to another Alpha Math video. In this lesson, we'll be focusing on the trigonometry section of the November 2023 past paper. Okay, so to start off, we have an equation given to us. Sine beta equal to 1/3. And the question also goes as far to say as beta is an angle between 90 degrees and 270 degrees. So not less than 90, but also not greater than 270, somewhere in between. Now, such an angle has to lie either between the second quadrant or the third quadrant. Okay? As you can see here, greater than 90 degrees would either be the second quadrant and onwards, excluding the first one, and 270 would either be from the third quadrant backwards. Okay, so somewhere between there would be the second and third. Now, also we note that sine beta is equal to positive 1/3, right? And sine is only positive in the first and second quadrant. Now we know it can't be the first because it has to be greater than 90 degrees. So it is in the second quadrant. Okay, I'm going to go ahead and draw a triangle. Right, that should do. Now, let's make our obtuse angle over here. That's beta. And the ratio for the triangles will be 1, that's our opposite, and 3, the hypotenuse. Because the ratio for sine is opposite divided by hypotenuse. Okay. Now, to find this adjacent value, we're going to go ahead and make use of Pythagoras. Okay, I'll do the calculation. Let's do it over here. X squared plus y squared is equal to r squared. Okay, now x squared is, or x would be this horizontal, the adjacent value. Okay, y squared would be the vertical one, so that's 1. So x squared plus 1 squared equal to r squared, which is the radius, or in our case the hypotenuse of the triangle. Okay, now let's solve x. X squared plus 1 is equal to 9. Then subtract 1, x squared is equal to 8. Take the square root on both sides, and x squared will be equal to plus or minus the square root of 8, which is 2√2, by the way. Now, I should point out this part. Since we know that x has to be less than 0, right? Just have a look at your Cartesian plane here. X has to be somewhere left of 0, okay, which is negative. Therefore, we know that x is equal to negative 2√2 and not positive 2√2, because that would be in the first or fourth quadrant, right? Negative x values is in the second or third quadrant. Okay, so coming back to our triangle over here, I'm going to get rid of that over there, and I'll just put in the value negative 2√2. Okay, now we have our opposite, adjacent, and hypotenuse values. So we can go ahead and answer our first question. Cos beta. What is cos of beta? I'll write it over here. 5.1.1. Cos beta is adjacent over hypotenuse. So the adjacent value is negative 2√2 and the hypotenuse is 3. And that's it. Okay. Question 5.1.2. This question was sine 2 beta. Sine 2 beta, again, here you can make use of an identity. Okay. The identity for sine 2 beta would be 2 sine beta cos beta. Okay, that's one of our special trigonometric identities. Sine beta, the ratio for that we know is 1 over 3 because that was actually given to us in the very beginning. And then cos beta we calculated here earlier, that is negative 2 root 2 over 3. Okay, I'm writing over that line, but I hope you can see over there. When you simplify all of this, so just multiply the numerators together, the 2 with the 2 and the square root 2, and then the 3 with the 3. And that gives you negative 4 square root 2 over 9. Okay, it can't be simplified any further than that. So that over there is just your final answer. Negative 4 root 2 over 9. Right. Now we can move over to our last question, which is cos 450 degrees minus beta. 5.1.3. Cos of 450 degrees minus beta. Right. Normally what I do when I have an angle that's greater than 360 degrees, I simply subtract 360. Okay? You can always just minus a revolution and the value of that expression won't change. So let's go ahead and do that. 450 minus 360 is 90. So we end up with 90 minus beta. And that's a cofunction. Cos of 90 minus beta is actually equal to sine of beta. Okay? The cofunction or co-ratio, however you want to refer to it as, of cos 90 minus beta is sine beta. And again, sine beta is simply 1 over 3. Okay, that's 1/3. And again, that was given to us in the very beginning, okay, in the start of the question. So that's how you would answer a question like this. Start by drawing a Cartesian plane in the correct quadrant, and that's very crucial, right? If you had the wrong or the incorrect quadrant, then a lot of this is just going to be messed up and you'll lose unnecessary marks over here. So just make sure you get the correct quadrant, and everything else from there flows, I guess. It was nothing really too hard. Right. Moving over to question 5.2. Okay, now this question might startle some of you, because you see cos to the power of 4. But in fact, this question is not too intimidating. Let me just write this all down. It maybe just appears to be that way. Prove that cos to the power of 4x plus sine squared x times cos squared x over 1 plus sine x is equal to 1 minus sine x. Okay. This question can easily be solved if we start with our left-hand side and factorize that numerator. There's a common factor on top. Okay. The numerator has a common factor of cos squared x. If you take out this common factor of cos squared x, so you have cos to the power of 4 and you take out cos to the power of 2, you are left with another cos to the power of 2. Okay. Now on this side, if you take out cos to the power of 2, you'll be left with sine squared, sine to the power of 2. Okay, and we also know that cos to the power of 2 plus sine to the power of 2 is equal to 1. Okay, so that just becomes 1. And we all know that 1 multiplied by something doesn't really affect the term at all. So basically our numerator is just cos squared x, okay, because the 1 doesn't affect anything really. I'm now going to change the cos squared x into an identity. The identity for cos squared x is 1 minus sine squared x. Okay, still we not yet, our left hand side is not yet looking like this right hand side. Right? So what do we have to do here? Factorize again. I'm going to take out, or in fact not take out the common factor, but rather make use of this difference of squares method, okay? Because 1 is a perfect square and sine squared is a perfect square. When you do difference of squares, open up a set of brackets, put plus and minus in each bracket. Then you write 1 plus sine x and 1 minus sine x. Okay, which is the square root of each of those terms. Now, this term at the bottom, 1 plus sine x, you can see it hasn't changed throughout. There was always that 1 plus sine x. Okay, it hasn't changed at all. Now, in the very last step, you can see here it's cancelling with the numerator. And we are actually now left with the answer that was required, 1 minus sine x. So therefore, we can say the left-hand side is now equal to our right-hand side. Okay, as required. We've proved this identity. Can I just quickly run through it again? We took out a common factor, cos to the power 4x plus sine squared x times cos squared x. Our common factor there was cos squared x. The identity for cos squared x plus sine squared x is 1. So you can see I just replaced that whole thing with 1. Then cos squared x also has its own identity, which is 1 minus sine squared x. And that can be factorized into difference of squares, which neatly cancels out with the denominator that was just chilling there all along, and we ended up with the answer we were looking for. So, a nice and easy question. Okay. Now, to follow up on that, it says, for what values of x is this expression undefined? And they actually give us an interval here. We need to solve x within that interval, 0 degrees to 360 degrees. But they say, where or what are the values of x is this expression undefined? Okay. Now, undefined, in mathematics, expressions are undefined when you divide by 0. Okay, so we know that this is not allowed. You can never divide by 0. Okay, and that means that this denominator here, which we are dividing by, can never be 0. So we're going to have to find out where this fraction is undefined. Okay, in order to do that, I'll say 1 plus sine x equal to 0. You simply set that denominator equal to 0, and you're going to find the value of x for where it is equal to 0, so that we can address the undefined values. Okay, sine x is equal to -1, right? You subtract 1 on both sides. Then, okay, I think the best way to do this is to make use of a graph, right? Let's graph the sine x function. Okay, so the sine wave would look something like this, starting at 0 degrees and ending at 360 degrees. It has an amplitude of 1, which means that the maximum value would be at 1 and the minimum value would be at -1. Now, it reaches its maximum at 90 degrees, then it goes back down to the equilibrium at 180 degrees, and then goes to the minimum at 270 degrees, right? It reaches this minimum here, which is -1, at 270 degrees. So, the solution for this equation here, where is sine x equal to -1? It's where x is equal to 270 degrees. That's the solution. Okay, and that's what they're looking. That's what they were looking for. An answer between 0 and 360 degrees. And this is the only place you can see from this graph. That's the only place where our graph is equivalent to -1. I will show you later how to solve trigonometric equations the more conventional way. But for that equation, as you could see, it's only 2 marks. So why go through the whole process when you can just read off from the graph. Now, question 5.2.3, it says, write down the minimum value of the function defined by, again we have this expression. So it's just a follow-up from that previous equation. We already proved that all of this is equal to 1 minus sine x. Okay, now they want us to find the minimum value of this function. Okay, so let's recap. The sine x function goes like this, starting at 0, ending at 360. This is for the sine x graph. Okay, just sine x. If it was negative sine x, which as we can see here, there is a negative sine x, the graph actually goes down first and then up. Okay, so it first goes down, reaching the minimum first and then the maximum. Okay, also 0 to 360, amplitude 1, which means maximum of 1, minimum of negative 1. Now, what does this plus 1 do? What does that plus 1 do? Well, that plus 1 actually just shifts the graph upwards with 1 unit. I'm trying to do it very gently like this. Okay, you can see here, if I were to draw a line over there and maybe just extend this y-axis, we can see now that the maximum would actually be at 2 because the graph went up 1 unit, and the minimum would no longer be at negative 1, but rather the minimum is at 0. Okay, this value over here is 0. So the minimum of this function, y equal to 1 minus sine x, would look like this. And you can see there that the minimum value over there is 0. Okay, it's at where I think the x value is 90 degrees. Yeah, x value is 90 degrees. And the minimum, the y value is 0. That's the answer there. Again, it's a 2-mark question, so just find the quickest way to the solution here. Okay. Now, here we have a compound angle that's given to us. They are stating that cos of A minus B is equal to cos A cos B plus sine A sine B. And given that we know this, can we now deduce that sine A minus B is equal to sine A cos B minus cos A sine B? Now, we already know that this identity is true, but you need to prove it, okay? So, and we're going to prove it using this identity. Okay, that's going to come into play later. Let me first just start with this. Sine A minus B. Okay. Now, sine A minus B, right? This can be equal to, and I want to make use of a co-function, right? You remember with co-functions, if you have sine of some angle, let's call it theta, then the co-function for that would be cos of 90 minus that angle, okay? I'm going to make use of that co-function idea over here. We'll say cos of, okay, let me use a bigger bracket, 90 minus, now I write the angle, A minus B, okay? So that angle is A minus B, whereas here the angle was just theta. Now, let's simplify a little bit. This becomes cos 90 minus A plus B, right? You distribute the negative here with the A and with the B. And now watch how I'm going to break this up. I want to make use of this identity that they gave to us. So I need to express this thing in terms of one angle minus another angle, okay? I need to write it like that. So I'm going to break it up like this. I'll say cos, so again, let me use bigger brackets. My first angle will be 90 minus A minus my second angle now, which is going to be negative B. You can see I'm rewriting this positive b as, or plus b, as a minus negative b. Okay, I'm rewriting the plus b as a minus negative b. And the reason for me doing so is I want to make use of this identity here. Okay, they say use the identity to deduce that this thing is equal to that. Okay, so there's a whole chain of steps I need to follow. So let's go back here to our question. Now, using that identity will be cos of my first angle times cos of my second angle plus sine of my first angle times sine of my second angle. Right. Cos of 90 minus a we know is equal to sine a. That is again a cofunction. Cos of negative b is still equal to positive cos of b. In fact, cos is the only function that is positive with a negative angle. Then sine of 90 minus a becomes positive cos a. Again, there's a cofunction identity. Sine negative b is negative sine b. You remember I said cos is the only function positive with a negative angle, which means sine is negative with a negative angle. Okay. Now, just to simplify this, we have positive cos a multiplied by negative sine b. When you simplify that, we get negative cos a times sine b. So you can see this negative times that positive creates a negative in front. Okay. And everything else stays the same. I'll just rewrite this as is, no changes over here. But now do you see what we end up with? We end up with that identity sine a cos b minus cos a sine b. And that's what we set out to prove. We wanted to prove that sine a minus b is equal to that thing. And we've just done that. You can have a look. We did exactly that. Okay, you can maybe just go through this one more time if there's something that didn't make sense. Yeah, hopefully it makes sense the second time you have a look at it. We are now going to put this identity into practice. Okay, so part 2 of this question, we have sine 48 degrees times cos x minus cos 48 degrees times sine x. This is equal to cos 2x. Using that compound angle identity of earlier, we can reduce this down to sine 48 minus x. That whole thing gets reduced to sine 48 minus x. Okay. Now, I need to solve x. I guess that's the question here, right? Determine the general solution of the equation. Okay. In order to do that, I'm going to have to change cos 2x into a cofunction sine 90 minus 2x. Okay, so we're seeing this cofunction, what do we call it, theme. This cofunction theme coming or happening over and over again. The reason I changed cos to sine is because now when we do this thing over here, this is called shift sine or arc sine. When we do that to both sides, the sines will cancel out and you are only left with the angles. So 48 degrees minus x equal to 90 degrees minus 2x. And let's solve x on both sides. So negative x plus 2x and 90 minus 48. This is just x and that's 42. So x is equal to 42 degrees. However, they did request for the general solution. So let me say plus k 360 degrees where k is an element of integers, all integers. Okay, k an element of z. Right. And actually what I've done here is I've only worked out the solution for the first quadrant. There is actually another solution. Okay, let me find that other solution for you. Okay. Sine is also positive in the second quadrant, which means we can't just make these angles directly equal to one another. 48 minus x is also equal to 180 degrees minus 90 minus 2x. Okay. So in the second quadrant, we have 180 minus, and therefore you say the one angle equal to 180 minus that angle. Okay, and we do this because it's sine. Okay. So 48 minus x equal to 180 minus 90 plus 2x. Just to simplify over here, I'll take the 2x over, and then this gives me a 3x. 180 minus 90 is 90, and then I take that over, and so this gives me 42 again. I have to divide by -3 on this side, so x is equal to -14 degrees. Let's just write plus k. This time I can't say plus k 360 now. I'll have to say plus k 120 degrees with k an element of all integers. Because we divided by 3, right? We divided these things by 3. And so you also have to divide your period by 3. So instead of saying 360, we say 120. Okay, which is 360 divided by 3. Okay. And this will be our last question for this lesson or this video. Here we have an expression. Sine 3x plus sine x divided by cos 2x plus 1. We need to simplify this into a single trigonometric ratio. Okay, they haven't told us what that trigonometric ratio is going to be, but we'll have to solve it. Find out what it is. I'm going to start by breaking up this 3x, because that's a triple angle. I'm going to break it up into 2x plus x. Okay, that's the only thing, or maybe let me change this as well, right? There's an identity for cos 2x that involves a -1. The reason I'm thinking about this identity is because I sort of want to cancel this plus 1 over here. So I'm going to change that into 2 cos squared x minus 1. And now as you can see, exactly how I pointed out, this minus 1 will cancel with that plus 1. Okay, that just becomes 0. Okay, so there the denominator is already simplified. But now what happens to this numerator? Okay, this now becomes sine 2x. I'm using the compound angle identity. Sine 2x times cos x plus cos 2x times sine x. Okay, and we just have this plus sine x chilling here at the end. And just watch what I did, right? This sine 3x broke up into this whole monstrosity over here. Okay, but we're going to have to simplify this. Okay, we can't just leave it like that. Let's see. I think we can break this up. Yeah, let's change the sine 2x into its identity, 2 sine x times cos x. Okay, but now you're going to multiply it with this cos x. So 2 cos squared x. Okay. I have another identity over here, but I don't know if I should use it immediately. Okay, let's leave that as is for now. I don't think it's useful to change that into anything just yet. So we'll leave it as cos 2x times sine x plus sine x. Okay. And maybe let me just let you in on what I'm thinking, so you guys can follow along with me. I want to take out sine x as a common factor. You can see every single term, right? So we have these pluses separating the terms. Every single term has a sine x, okay? And so I'm going to take out sine x as a common factor. Okay, let's go ahead and do that. The numerator will take out sine x as a common factor. And here you'll be left with 2 cos squared x. You see, it's the 2 and it's the cos squared. Plus, now you know what? I think I'm going to use this identity again. For cos 2x, I'm going to rewrite that as 2 cos squared x minus 1. Okay? And remember, I removed this sine x because I took it out as a common factor. So that's no longer there. And also, when we divided this by sine x, right, by taking out that common factor, sine x divided by sine x is just 1. Okay. So, the same theme plays out here. You again have this minus 1 that cancels with a positive 1. Okay. And divided by 2, let's just scroll down, 2 cos squared x, okay. So, add up like terms inside the bracket. 2 cos squared x becomes 4 cos squared x. And this is divided by 2 cos squared x at the bottom. Cos squared cancels with a cos squared. And 4 divided by 2 is equal to 2. So this becomes 2 sine x. And that's it. That's your final answer. We simplified it all the way to this single trigonometric ratio. And if you go back to the top, let's have a look at all the rabbits that we had to pull out of this hat. Sine 3x. We had to break that up into 2x plus 1x. Then we made use of a compound angle identity here, changing the sine 2x plus x into this whole big identity. The next thing we looked at was, what was it? Oh, the sine 2x. We changed it into 2 sine x cos x, but that cos x got multiplied with this cos x, which became cos squared. Okay, and over here I didn't know what identity to use yet, so I left it as cos 2x. You can see here we still left it as cos 2x, but in the next line I immediately knew what identity to use, so I changed it to 2 cos squared x minus 1. The reason I chose this identity is because I saw I also have a 2 cos squared x, right? And we could add them as like terms. So that's what I noticed there. And also the 1's cancelled, so that was sort of like a bonus. You could see here the cos squared also cancel, and we ended up with our final answer. Awesome. Okay, I hope you guys enjoyed this and learned a bunch. I'll see you guys in my next video. Maybe we'll do calculus or something else. Bye.